JavaScript is what is called a multi-paradigm language, which means that I can regard the language from different perspectives and use it from different perspectives, and I can have really different code. This is a trend which exists in all languages. As time passes, languages tend to become feature sets. And if you think about stuff which you would have said would never be present in Java or in C#, it's appeared in Java and in C#. Right? You can have lambdas in Java. You can have variables which are defined without a type in C#, and so forth. JavaScript started as a multi-paradigm language, and its main paradigms have been these. So it's an imperative language, and this is something it has in common with other, let's say, interpreted languages, in the sense that you can opt to write code in JavaScript, which is really simple. Right? I can write code in JavaScript which uses none of the more advanced mechanisms in the language. It's going to be bad code. It's going to have a low level of abstraction, but I could write code with a second grader. Right? I could take a second grade child and write code in JavaScript with them. And to understand this, let's think about something. Have you ever run into Scratch, which is a programming language based on diagrams? Nobody knows what Scratch is. Well, it's going to start being taught in 5th grade from this year in Romania. And Scratch, let me just find the program. Scratch actually looks like this. No, it doesn't look like this. It looks like this if you look at the code. Right, so I have something which is very much like a flowchart. Now, let's find the higher resolution image. 1 second. This is one. Okay, so let's look at the simplest one, right? When event prints something and then stop, right? Okay, and what's interesting is that is how Scratch is actually represented internally, because under this diagram stuff, there's a domain-specific language, so something which looks like tags, basically. But under this one, it's actually JavaScript, and it's really similar to JavaScript. And this shows you that the concepts in JavaScript, not the syntax, but the concepts have been taught as really easy to understand for small children. This is the language of choice for teaching the beginnings of programming. The syntax is C-like. Now, when talking about C syntax, there's two kinds of programmers. The ones who, when first saw C syntax, thought, "Oh, how elegant," and the other half which said, "Oh, how terrible." It's a matter of personal taste. I was in the first category, but I'm not holding it against anyone. So the syntax is really similar to C. Now, there's a reason for this, which is that we can shorthand a lot of things. So when I say what are the operators in JavaScript, I can actually say they're the C operators plus 1 or 2. Or when I say how do I write a classic for in JavaScript, it's going to be the for in C, but adjusted for a dynamic language. Okay, so JavaScript is imperative. JavaScript is functional, and it's functional in a way which is really, really powerful. When I'm talking about functional languages, I'm not just talking about sending functions as parameters, what I can do in Java, for example. I'm talking about functions as values. Now, we're not going to explore the whole suite of consequences of this today, but in the next course. But it's, for example, I can have functions which return functions, and which basically creates polymorphic behavior. And I can do this in such a fashion that my code is still going to be readable. Right? I'm going to have something which is a useful level of abstraction. Then JavaScript is an object-oriented language, but JavaScript is an object-oriented language debatably in a simpler or by a simpler definition than the definition you've encountered until now. The languages we've encountered until now are what are called classic languages. And classic languages are called that because they have classes, right? And JavaScript doesn't. And the fundamental difference, to explain it, is that if I think about I think about an object which represents a chair, right? And my chair I might regard it as an instance of an ideal idea of a chair. Right? There's an ideal idea of a chair, just the ideal blueprint of a chair, and this is an imperfect representation. And this is somewhat how classic languages regard things. So I have a class, which is something different from object, and then I have representations of that class instances. Now, if I think about JavaScript, JavaScript is actually a prototypical language, which means that in the thing which is common among objects of the same type is not going to be an ideal representation, but rather a concrete object. So imagine that if I want to create chairs, I'm going to have an actual chair and going to use that as a prototype. I'm going to create every other chair as a copy of that one. Right, so this is the idea of a prototypical language. We're of course going to come back to this one. The second thing is, again, it's the Romanian version. Sorry again. Okay. One sec. I'm going to fix it. The language is interpreted, which is it's not compiled. Now, the language is interpreted initially was a language which was run in a sandbox environment, right? It was invented to automate stuff in a graphical user interface which ran in a browser. The language is interpreted, and apart from this is not such an important thing, but what is important is that the language is relatively inefficient. Although this distinction might fade in time, because I have some modern approaches to this. JavaScript, for example, to give you an example, JavaScript doesn't have integers. JavaScript just pretends to have integers, but represents everything in floating point. Now, if I think about how I optimize code, which involves numbers, it's clear that I wouldn't be able to optimize it as much as in the case that I would have integers, right? Now, that being said, stuff has appeared which is going in the direction of solving this. For example, have you heard of WebAssembly? Yeah, WebAssembly being sort of binary code run in the browser. But actually what's happening there is that I have a subset of JavaScript which is highly optimizable. And then I can bypass the limitations of the language in terms of speed. Now, JavaScript is dynamically typed. This can and does mean several things. First of all, and we're going to just run some experiments to investigate this. First of all, what's going to happen is that in JavaScript, this is my console, which I have in any browser, in JavaScript, types are going to be changeable at runtime. So for example, if I say something like let, which is one of the ways I can define a variable, a is 5, right? And then I say a is going to be 5. And the type, this is going to be a special operator which I can find in basically any language, is going to be, in this case, number, whatever that means. Now, if I say a is some string, a is now going to be this, and type of a is going to be string. I can change it dynamically. This is one of those with great power comes great responsibility cases, though, of course, but it's part of the power of the language. So no, I wouldn't want, for example, to have static typing. It wouldn't improve the language, right? I like dynamic typing. Now the second thing is that the language is duck typed. Duck types is well, it's sort of a joke which says that if you have something which quacks like a duck and works like a duck, it's probably a duck, which is a way of regarding interfaces to things. So if I have an entity somewhere, and it behaves sufficiently to fit the place I'm using it in, I'm going to consider that it's all right. Right, so if I treat something like a string, and it behaves sufficiently like a string, it's going to be treated, the code is going to work, right? And the JavaScript is a really permissive language. Let's see something like this. For example, let's say I'm doing this. Right, so this works. Why did this work? Well, the mechanism is somewhat interesting because, as an aside, JavaScript is what aims to be a purely object-oriented language. Now, purely object-oriented means everything is an object. Now, this is partially true in the sense that I do have some primitives, but the primitives are auto-boxed. So whenever I try to use them as objects, they're boxed in objects which correspond to the primitive type. So if I have a number primitive, I'm not going to be able to access the number primitive directly. What's going to happen is that if I treat it as an object, it's going to create a number object which wraps the number primitive, and then I treat it like that. So in this particular case, I can't add a number primitive to a string primitive, but what I can do is concatenate the string representation of a number object to the string representation of a string, which is the string. It's strangely said, I know. Right, so that's why it gives me 65. But the language is really permissive. Okay, initially it was client-side, but then it got more types of interpreters. What we're going to work with is the client-side variant and the server-side variant. And if I think about it, it's going to be really clear what the difference between the two is going to be. Some things which make sense on the client are not going to make sense on the server. What I have on the client is something which runs here, right? So it's sandboxed in my browser. What I have on the server is a console application. And let's see what wouldn't make sense. Where in the client, something like window would make sense. Right? I can't imagine my browser without having my window object, right? So let's see. I have an object which was created by the browser, and it's going to be window. On the server side, though, if I run a console application, would window make sense by default? Well, no. Right? It's a console application. Now, conversely, if I'm on the server, I might want to list all files and folders in the root of my file system. Right? Maybe I'm automating something. Would I be able to do that on the client? Should I be able to do that on the client? Would that be acceptable? For security reasons, right? We'd dismantle the internet if we have that feature. So I can't do that. So it's the feature set, the potential feature set is limited. Now there's JavaScript for desktop applications. There's JavaScript for little robots. Obviously, JavaScript for little robots is going to have other libraries. Although the language is going to be identical, I'm going to have other libraries depending on the form of JavaScript I'm using. Okay. So initially client side, okay. This is what I've already said. Now JavaScript is fundamentally asynchronous. Most of the things I'm doing are things which I invoke, and then I'm going to wait somehow to be notified that that particular operation has been done. This creates some problems if you've not encountered asynchronous programming before. It creates some problems even if you have encountered asynchronous programming before, because what's going to happen is that JavaScript code, synchronous and asynchronous code, is going to be hard to mix. And that's going to mean that I'm going to write code which is difficult to maintain. And this has a colloquial name which is callback hell. Right. So let me show you an example of what I mean. Let's say let x is, let's say I'm going to have this, so let x is result get sync something, right? And then I'm going to say console warn of x. Is this going to work? Oh, sorry, it's not visible. Is this going to work? What's going to happen here? Does this make sense? If my function is asynchronous, do I know that at the following line I have an x? The answer is no, right? I've asked it to do something asynchronously. This might take a bit of time. It doesn't matter. It might be something trivial, which I'm going to do immediately, but it might be something non-trivial. For example, if I make a web request, I don't actually know how long it will take, and I don't actually know if it will work, right? So this is the problem. And we have a series of solutions to this. We're going to discuss them next time. Some are traditional solutions, such as callbacks and events, and some are basically a design pattern which is integrated in the language now and which is really useful for this case, and which is promises. Right? So it's treating everything in terms of future values. And promises are going to allow us to treat stuff which we want to treat asynchronously, but to have the option to treat things which were asynchronous as being synchronous, to write them in a little series of operations. Okay, so everything is built on the asynchronous model, and this fits for some things naturally. For example, in the browser, if you think about designing a language for the browser, it's obvious. You're going to say, when am I supposed to run my code? Well, when I have an action of some sort. Right? The user clicks the button, or the page loaded. If I run JavaScript on a little robot, the little robot fits very well on the asynchronous model, because you say, I get something from a sensor, and I have to do something with an actuator. I get something from my infrared sensor, and I have to start some little motors. Okay, but if you're writing something on the server side, which is insert some stuff in a database, right? That doesn't really make that much sense. Sure, you could treat them as asynchronous operations, but they're going to be performed instantly. And you might get better code by just pretending that they're synchronous, by just waiting for them. Right? It's from my perspective, from my code, something like locally inserting something in a database is basically instant. It's not something which I can say I have to realistically wait for. Now, the language is case sensitive, and it uses Unicode as its native character set. So I can of course write my variables with national characters, but that's a bad idea. But I can process string, which is in a national language, right? Which is a better idea, because I might want to write something in Romanian or something like that. Now let's get into some discussions over the nature of the language. Now there's something you might not have encountered before, which is a discussion on function scope versus block scope. Now, what would block scope mean? How are variables scoped in something like Java? If I'd have these two alternatives, how would I say they're scoped? Where is the variable visible? Well, by default, in Java, Java has block scope. Variables are visible within the block they're declared. Now, JavaScript has here a bit of strangeness, which is unnecessary, which is it has function scope, which means variables are visible until the first function they encounter, not the first block. So you can have something really strange. Let's look at something really strange. I'm going to do a for, and the for is going to look as I'd imagine a for a dynamic language would look if it would copy the for from C. So instead of int something, I'm going to have var something, var I equals 0, I less than 10, say, I plus plus, and we're not going to do anything. We're just going to run the for. Right? So in any other language that you've encountered until now, what is the value of I now? I don't know. It's undefined, right? Well, in JavaScript, it's actually 10. Which is strange. This is function scope. Fortunately, we have a way of bypassing this strangeness, because the way I'm declaring things is var something here, and var something declares things which are block scope, which are function scope. But I also can declare things with let, and let just declares things which are block scope, and it makes the language more intuitive. Now, when I'm saying declaring things, this is an interesting discussion, because when I'm declaring things for example, if in C I'm saying int I, what do I know about I? I know something about I. I know that the name of the symbol I'm declaring is I, and I also know that its type is int, right? But when I'm saying something like let I here, it's already defined. So let's j. What do I know about j? I only know the name of the symbol, right? I don't know the type, and I don't know the value. So there's a level of unknown that I can reach in JavaScript, which is higher than what I would have been able to reach in a statically typed language. Now, however, what use would this have? Why would I do this? If I look at J, it's undefined, and undefined means what I've already said. But why would I use this? Well, let's look at our vision of scopes and JavaScript in a different fashion. Now, if I think about objects, for example, and I and I think about the simplest definition for an object that I could make, what would be the simplest definition? That's not the simple definition, and it's language dependent. I just said that I don't have classes, and I don't need classes. So no, let's make a try at it. It's going to be something which groups characteristics and behavior, right? Which is doesn't go into any of the details. However, if I think about the idea that functions are treated as values, characteristics and behavior are not going to be all that different, right? Because the values might be something like age 5, or they might be something like walk some function. And objects in JavaScript are fundamentally a list of key value pairs. And some of the values might be functions. Some of the values might be other objects, and so forth. Now, if I extend this line of reasoning, and I think about the scope, right? An entity within which some variable names are visible. I could think about the scope the same way, right? As a list of key value pairs. So what I've actually done here is just say that the key J is valid, even if its value is not yet defined. Does it make sense? Yeah, so I can think about a lot of things in JavaScript in terms of key value pairs. And structurally, this makes for a really simple and elegant language. Okay, now getting back to this. Now, an inner scope, let's say, doesn't contain the variable I'm looking for. In any language, I look in a containing scope, right? So if I'm inside the for example, and referring some variable, I'm going to look in the containing scope and see if I can find it there. So I have something which is a scope chain. Now, if I think about the idea of a scope chain, how would I achieve this when constructing the language? Well, I might achieve this by having within the inner scope some sort of reference to the outer scope. And this is going to have an influence later, but I might represent it like this, right? So I'm in a little box, and the little box has to know within which larger box it's contained. Okay, now when declaring variables, I can declare them with var, and we've seen this, and this declares variables which are function scoped. Now this doesn't have that much use, and it's confusion generating. And in JavaScript 6, I have let and const. Const gives me the possibility of defining constants, obviously, but let gives me the possibility of defining things which are block scopes. Now that being said, I still have to know how var works, and I should still be familiar with function scope, because there's a lot of JavaScript code out there. It exists. Right? That's the main reason why the language didn't switch from function scope to block scope, but rather added a separate keyword in order to maintain compatibility with pre-existing code. Okay, so data types. I said that JavaScript can be considered a purely objectual language. So it's a language in which everything is an object. Is a function an object? Yes. Is an array an object? Yes. Let's test this out. Right. So let's say I have an array, and an empty array is going to look like this. Right. Right. So this is going to be a property on my array. Let's try a function. Let's say the array contains a function, and I'm wondering if the function itself is an object. So see, when I'm saying a particular array.map, whatever map doesn't matter at this point. I see that map actually contains a function. Right? But is this function an object? It actually is. My function is an object itself. Okay. What would the length of a function mean? Well, it's going to mean it's called the arity of a function, and it's the number of arguments. A function object is not actually that interesting, but it's an object nonetheless. Okay, so everything is an object. Now this doesn't actually hold true. I do have some primitives, but the primitives are, like I said, auto-box. So if I look at something like this, and I say type of, it's going to say string, right? While I can say type of new string of 5, and this is going to say object. But this is, apart from some really specific situations, is going to be invisible to me. They're going to behave identically. So if I try to do something string-like on 5, it's going to work. It's going to be packaged in a string, and it's going to work. So I'm going to say well, 5 is not a good thing. Some string to uppercase. Right. That's going to work, even though it's ostensibly a primitive. All right. So we can agree with this partial fiction that the language is purely objectual. Now I have string, numeric, and boolean, which are going to wrap primitive text. String is going to wrap character strings, obviously. Now character strings can be defined either like this or like this. This is again something which we might encounter in different languages, because it's going to allow me to do less escaping, right? So if I want to do this, it's going to work. And if I want to do this, it's going to work. I mean, I don't have to escape it because I can just use different string delimiters. Now, if I do want to escape something, I do have escape sequences, and they're the escape sequences you've already encountered in C, which means that backslash double quote is going to be an escape double quote. A backslash backslash is going to be an escape backslash. Backslash T is going to be an escape tab, and so forth. So it's like in C, and we have this shorthand. Okay, now apart from these, which are basic types, I'm going to have array and object. Arrays are going to be something which is actually not quite an array. They're called arrays, they're not arrays. So if I think about arrays in C, these are not arrays, they're more like lists. So they're more like collections. And arrays in JavaScript are supremely overloaded. So if I think about a list of things, what are the minimal what operations do I need in order to manipulate a list? Well, I need positional access, right? So I have to be able to say my list of 5 somehow. It doesn't matter what the syntax is. Takes value X or give me the value of my list of 7. Okay, so I have this. Now, if I take this list and also use it as a stack, what should I have? Well, I should have operations for adding and removing at the same side of the list, right? It needn't be the end, because the stack I could just flip it around and it's still going to work. So I have to, for example, be able to add and remove from the end. Now, if I have all this set of operations, and I also need to use it as a queue, what else do I need? Well, I need something to be able to add at the start, because I already have something which takes from the end. And the arrays in JavaScript do everything that I've just said. Arrays in JavaScript can be sparse without any particular effort. So if I have valid indexes 1, 2, and 7, this is actually going to work. And if I try to access index 5, I'm just going to get that the value is undefined. It's going to seamlessly work. So they are supremely overloaded. We're going to see at the tutorial the operations we can do on arrays, but we can do a lot of things.
But those undefined values between 2 and 7, do they occupy memory?
It's an interesting question to which I can't answer right now, but I think they don't. It depends on how array is written. Right? But I can do something like this. So I can say let A is 0, 1, right? Sorry, can't seem to write. Right, so this is an array with 2 elements. And then I can say t of 7 is 7, right? And now, and if I say t, it looks like this. It depends on the internal representation. I can find out for you and tell you. Okay, and I can seamlessly iterate through this. So it's valid. I can actually say from 1 to 7, right? Because the array length is going to cover everything. Okay, so then I have objects. And objects, we've already introduced objects in principle. Because I can have objects which are represented really simply, right? I can represent objects as key value pairs. And some keys are going to contain functions, methods in this case. Some keys are just going to contain some values, some regular values, because functions are values and I might create ambiguity. They might contain a number or a string or something like that. Some keys might be special in the sense that I might actually refer to another object. And if I think about it, how would I implement something similar to an inheritance mechanism? Well, I might just have a reference to my parent. Because, like I said, in JavaScript, I don't have classes, and the thing which is common between objects of the same type is a concrete object. If it's a concrete object, I can have a reference to it. So it has space allocated, it has an address in memory, it's a concrete object. Right? So I might have a little link to it, a reference to it. And this is going to have some really interesting consequences, because the language is dynamic to an absurd degree. For example, if I might want to modify a type at runtime, I'm going to be able to do it. If I might want to modify the idea of a string at runtime, I'm going to be able to do that too. I can modify the concept of a string, add something to the idea of a string. And this is going to be applied to all strings. Now, why? Well, think about what we talked about when we talked about the scope chain. So if I'm looking for a variable in my current scope and can't find it, I'm going to look on the enclosing scope. And I can find my enclosing scope because I have a reference to it in some fashion. Okay? Now think about objects. Let's say that we look from a similar perspective. When I'm looking for the value of a particular key on my object, let's say I don't find it. What I'm going to do then is think about the object's prototype. I'm going to have a reference to my prototype, to the thing defining how all objects of my type behave. So I'm going to go via that reference and look on my prototype. And this is really similar to what I get for inheritance, but it's maybe somewhat more intuitive. Now, if I don't find something on my prototype might have its own prototype. And this is going to be a prototype chain. Does it make sense? So I just have a series of linked little boxes containing key value pairs. Okay, so I have already an object. An object is going to look like that. This is an empty object. Now, obviously, this empty object in this case, okay, it actually has a prototype, and the prototype is going to be object. And there's, of course, an object type, which is going to be what all objects have in common. Doesn't matter for now. They have some behavior in common. To recognize something which you've found in other languages, I'm going to have a toString, for example, for all objects. All this other stuff actually has some use or another. We're going to look over them when we talk about objects in more detail. Okay, now I also have some special types. These are going to be null and undefined. Now, if I think about null and undefined, I have to understand that in a dynamic language, I'm going to have different degrees of non-determination, let's say. So if I think about something which has a type, but doesn't refer a valid object, that is going to be null. It's the same as in Java or in C# or wherever else. However, in JavaScript, I can also have a higher degree of non-determination, which is something for which I don't know the value, but also I don't know the type. And we've already seen this, because when we say let something with no value, that's going to be with unknown type and unknown value. And I also have symbols. Now, symbols, think about them as keys which have general significance. For example, the discussion about symbols is more complicated. In case we can cover during this semester everything we need to cover faster, we're going to go back to metaprogramming in JavaScript and play with that a bit. But they're tied to a more complex way of extending the language. So let's say we want to define in the language something which was not defined before. The idea of things which are iterable, right? The concept of iterating through things. And we might want this concept to be available and to have significance cross-library, so in different parts of source code. What we'd use to guarantee this uniqueness, the uniqueness and the commonality of this concept would be a symbol. But this discussion is going to be way over what we're trying to do, because we're not going to do this ourselves. So I'd have a symbol which would represent the concept of having an iterator. Symbols have been introduced in JavaScript 6. Now these are my primitive types. They're actually with lower, not with capital names. So I'm going to have this type of 5. It's going to be number. Type of this is going to be string, and type of false is going to be boolean. Like I said, they're auto-boxed. Now strings. These are some defined strings. Like I said, I can define them with single or double quotes. I can switch quotes, and if I switch quotes, I don't have to escape anything. As a point, the semicolon at the end is optional. I can just write them on different lines and it's going to work, which I'm often going to do. I can use C-style escape sequences. Now numbers I said are all floating point. I'm going to have some functions in JavaScript which are going to refer to integers, but they're not actually working with integers, right? What they're actually doing is truncating things, right? So I'm going to have something like this. For example, I'm going to say parse float of 5.4. This is going to give me the number 5.4. It's a conversion function which takes a string and gives me the number, assuming the number can be obtained. And I'm also going to have this. This is going to give me 5. But this 5 is actually still represented floating point. This has two consequences. One of them is the speed one, which we've already talked about. And the other one is that floating point numbers are fundamentally imprecise, right? If you think about the representation of floating point numbers, if I multiply two floating point numbers, I'm going to have a loss in precision, which means that there are going to be at least some financial calculations, which if implemented via JavaScript numbers, are going to give me the wrong value. Okay. I can also do explicit numbers. This is an explicit number object, numbers as explicit objects. Pardon. Now booleans. Booleans, of course, have values true and false, but in JavaScript, I have truthy and falsy values. Now you've encountered similar concepts to this before. If I think about C, and I say if something, and then I run a block. What can I have in the parentheses for if to obtain false? What is the if not going to go into the block? When in the parentheses I have what? Yeah, 0, for example. Anything else? Do I have false in C? No. No. Right? I can have no. Okay. This is going to apply to other languages. Because if I think of Java, I can have something which is a Boolean false, because I have false here. But I can also have something which is a no reference, and it's going to be false. Well, this is a bit more extended and a bit less intuitive in JavaScript, in the sense that I do have some faulty values, and they're going to be this. they're going to be false, obviously. The empty string, the numbers 0 and minus 0, assuming they exist, so it's 0. I have floating point numbers. Floating point numbers support two values for 0. Right. Undefined, no, and the special numerical value which is not a number. I get not a number, for example, by doing a conversion. If I want to convert ABC to a number, it's going to give me not a number. Not a number is a special value, and it has the characteristic that it propagates through any number of arithmetic operations. So I can't do any arithmetic operation on not a number to give me something which is a number. So if I add it with anything, it's going to be not a number. If I multiply it with anything, it's going to be not a number. If I shift it, if I raise it to a power, it's always going to have the result not a number. Okay, so these are my falsy values. All the other values are truthy. And we can test this out really easily. So I'm going to say, let's see how an if is going to look like. An if is going to look very C-like. So if, for example, the empty string is console log I am true. So nothing. So if we negate this, it's actually I am false now, but you get what I'm saying. Now, some stuff is not falsy, although it might seem like this. So an empty array is truthy. An empty object is truthy. Okay? So I have to know what truthy and falsy values. I have to actually know the list. This is somewhat non-intuitive because I might say an empty array is truthy because it's obviously an object. It has stuff in it. An empty object is truthy because it's obviously something which contains some methods. What? Right, so I can see some structure here. Now, however, this one is falsy, although it also contains some stuff. Right. So this makes sense. However, it's falsy, so it's not necessarily intuitive. Just a list of values which I consider false. Okay, and my complex type are going to be array and object. Arrays are zero-based, like I said, and arrays are going to represent a list of objects. Right. So this is, I can declare arrays however I want. So like this, like this, like this. This is going to be preferred because it's simpler. Arrays are objects, like I said. Objects are actually, I can create hierarchies of objects, and the objects can be represented in something which is really similar to JSON. So they're going to JavaScript object notations. That's why it's called like that. So let's say age 5, right? Name Timmy, right? This is going to create something which is actually an object, but which looks really similar to a list of key value pairs. Now the keys are actually going to be strings, but the strings are not explicitly written as such, because I can. But I can actually write them like this. And I'm going to actually get the same result. And this looks exactly like JSON, like JavaScript object notation. Okay. Obviously, objects can function like hash tables. Should I need that? An object can be initialized via the new operator via this representation, like I saw. What's going to happen here, though? Because I said I don't have classes. So if I say new car, what could car be if it's not a class? What do they have here? Because obviously the constructor thing, it looks really similar to other constructor, other languages where I met a constructor. Well, what's going to happen here is the definition of stuff which is common against amongst objects of the same type is going to be done by just defining the constructor. And the constructor is going to be a regular function. The difference between the constructor and other functions is that it's going to have significance when it's going to be invoked with new. This is just an invocation pattern. Think about it like this. If I think about functions, I could invoke a function standalone, or I could invoke it bound to an instance of an object, and then it's going to be a method invocation pattern, right? So a function invoked by itself is going to function like what I regularly see in other languages. A function invoked on a particular object is going to be aware of what this is, what the current object is, right? A constructor, in this case, is going to do something else. It's going to allocate memory space, run its own code, and then return to a reference to the particular this it works with, to a particular object, the object that was created and initialized. Does this make sense? So it's just a way of calling a function which allocates memory and returns a reference to that memory. Okay. Like I said, null means I don't know the value, undefined means there's no value and no defined type. I have a series of conversions, right, which are done implicitly. And let's see something strange and think about what happens. So I have 5, the string 5, and I say equal to 5, and it says true. How could this be true? In what perspective is this true? What would happen if I do something like this in a statically typed language? Would it be true or false? It's a trick question. It wouldn't make sense. I wouldn't be able to do this in a static. It's not a matter of true or false. It's a matter of comparability. They wouldn't be comparable. Yes, they're transformed into. I do conversions to string, and what I'm actually comparing is string representation. And this actually leads us really nicely to operators. And when talking about operators in JavaScript, I'm going to encounter all the usual suspects, all the operators from C, mostly in the same precedence. What I have which is specific to JavaScript is that I'm going to need another kind of equal, because this equal obviously doesn't cover all the cases. These are equal from that perspective if I do all the conversions, but they're not as equal as these two. Right? These are equal in a totally different sense. Well, I'm going to thus have the need for this operator, which is equal, which is going to be translated as equals and has same type. And this is going to be false, because they're equal, but they don't have the same type. Obviously, these two are going to be equal in this sense too. So this is the one operator which is going to be specific to JavaScript and which you've not encountered in. But the rest of the list of operators should be familiar. You should know how everything works. Okay. Conversions. So number to string. Right. So I have a new string. I can pass it a number. That's going to work. There are also dedicated conversion methods, which create the string which is correspondent to a particular representation of the number. Because think about it. If you have a floating point number, you can write it in exponential notation, or you can write it in our casual notation, right? So something which reflects the internal representation, which is exponential notation, and something which doesn't. Right? So let's look here. So okay, this is going to be this. Let's say 5. I think it's like that. 1 sec. Let me just clarify that. Okay. right? So this is exponential notation, and so forth. Boolean to string the same way, string to number. Now string to number, I can actually use the constructor of number. The result for this is going to be 5. The result for this is going to be 0. Because why not? Okay. The result for this is going to be not a number, intuitively. And that's what's supposed to happen. The result for this is going to be 5, and for this is going to be 5.2. And if I do this, for example, %, of 3.2 plus parse float of 3. What's the result going to be? Of 3.2. Sorry. 6.2, correct. What if I do this? Okay. One sec. What's the result going to be now? Yes, 333.2. Because it's conversion to int 3, concatenated with the string, the only thing that makes sense, 3, concatenated with 3.2.
So what do you move the string to the last one?
It's going to do the plus first. So it's going to be 6.2 concatenated with 3. Right. I'm trying. Right, so it's 6.2 concatenated with 3. Okay, we're running out of time. So let's go relatively fast through this. Sorry, I'm going to keep you a bit longer. So I have automatic conversions. Adding a number to a string, we saw it will produce a string. Object to a string will produce a string because it's the valid way of thinking about it. Printing an object to the console is going to produce a string. It's the string that corresponds to the object is going to be the string representation of the object. The object has a toString method, and I can define it. I can overwrite it. Right? I can say how the string is how the object is represented as a string. Now, obviously, I have a series of operators. Like I said, they're the familiar type of operators. Everything. Now, plus between a string and a number will produce a string. Obviously, the operators plus and plus equal are overloaded for strings, right? So it's between numbers they're going to do addition, between strings they're going to do concatenation, just like in every language ever. And I think we have to sort of stop here. Now, when talking about flow control, I'm going to have everything I'd expect to have from C, right? So I'm going to have an if, which is going to an if else, which is going to work exactly like in C. I'm going to have a classic for, so the for with 3 statements inside it, which is going to look and work exactly like it would in C. I'm going to have a while and a do while, and I'm going to have a switch, and they're going to work exactly like in C. But I am going to have something else, and we're going to probably see these next time, which is I'm going to have a for in and the for of. And the for in is going to be something JavaScript specific, which is going to iterate through visible properties. It's like an iterator through a list of key value pairs. And I'm going to have for of, which is going to be the equivalent of for each. Something which says 4 elements for each element of a collection. I think we're going to stop here. Do you have any questions?